The diagram on the right shows two congruent trapeziums with a pair of sides of equal length. Calculate the value of x. The keywords are two congruent trapeziums. So if congruent, meaning that it is same size and same shape. If size is the same size, it means that all the length, corresponding length and angle must be the same, right? So we just make sure we are doing the right side and angle. So we will use a parallel line for trapezium, and we can find the we call as alternate angle or corresponding angle. You can use alternate or corresponding angle. Okay, so 68 plus x should be equal to 180 degree. So x should be 180 minus 68. So the answer is 112 degree. Let's proceed to question number 2. The diagram on the right shows two similar geometric objects. Calculate the value of y. The keywords here is similar. When you see similar, it means it is actually having same shape but different size. So for the bigger one, corresponding side y and 6, you find the ratio and you compare and equate to the 14 correspond to 8. Alright, corresponding side. So hence y is 10.5. So meaning that similar, meaning that same shape and different size. So we assume that the ratio should be the same when we find the corresponding side. Question number 3. The diagram below shows that Q is the image of P under enlargement. Describe the enlargement. Describe. So when describe the enlargement, we need a scale factor. How to find scale factor? We must find the corresponding side of the image divided by the corresponding side of the object. The pink one is the image. So we count 1, 2, 3. We have 3 units. Corresponding to this side is just 1 unit. So that means the scale factor is 3 divided by 1. Alright? The scale factor is defined as length of image over length of object. Remember that when the image becomes bigger, the scale factor will be more than 1. So logically it's right. Scale factor is 3. So we will write enlargement with scale factor 3. How about the center of enlargement? We need to identify the center of enlargement by connecting the 2-point object and image, and we draw the line. Okay, another object and image, another point, we draw another line, and the 2 lines will intersect at the enlargement point, which is in yellow color. So if you read carefully, it should be 3, 3, right? So now the description is enlargement with scale factor 3 about the center 3, 3. Description must have 3 important keywords: enlargement, scale factor, and the center. Question number 4. It's given that the area of shape A and shape B are 18 cm square and 32 cm square respectively. If shape B is the image of shape A under an enlargement, determine the scale factor of the enlargement. So we are going to find the scale factor for the enlargement. So according to the formula, scale factor square is equal to area of image divided by area of the object. So 32 centimeter square is actually the area of the image, and 18 is the area of the object. Therefore, we can find the K. So we have positive and negative. If we square root 16, we have positive, negative 4. Same also for 9, we will have two values, right? So the answer should have positive and negative values. As you know, if negative, the object and image will be at the opposite side, refer to the center of enlargement. If positive, they will be at the same side of the center of enlargement. Alright, let's proceed to the next question. For question number 5, the diagram on the right shows that point A lies on a Cartesian plane. It is given that transformation R is a translation phi -2 and transformation S is refraction on the line y equal to 7. State the coordinates of the image of point A under combined transformation RS. So let's highlight the important keywords transformation S, which is the transformation that we are going to do first. So it's a refraction in the line y equal to 7. So we draw y equal to 7, and then we do refraction for the object A, point A, 3, 4, and we get an image which is in green color. Object is blue color, image is green color. Alright, so that is the image. So let's read the coordinates for the image is actually at the 3, 10. So after we do S, we will do R. So R is translation 5. So we move 5 steps along the x-axis, same direction with positive x-axis, and then we shift down 2 units along the vertical direction or y-axis. So -2 means shift down. Okay, so that is the final image. Alright, so the final image is at the 8, coordinate x is 8, coordinate y is 8. So the final image is 8, 8. So the coordinate of the image of point A under combined transformation RS is 8, 8. So we need to write the final image for this question. Now in SPM exam, you can write like this. You start with the object A, 3, 4. After you do S, you will get the first image, right? Okay, after you get the first image, you can write down. Maybe they can give you 1 mark for the A first prime, A prime. Okay, for the A first prime, you write down the point before you do the R. So that means we are going to write the answer for the A after we do refraction y equal to 7. We will get the answer. We will write down first the answer, which is actually at the 3, 10. It must be perpendicular distance to the object. Object is in blue, image is in green color. So actually you can write down the image, which is first image for A prime is at the 3, 10. Followed by 3, 10, you can take the 3, 10 plus with the 5 and -2. 3 plus 5 is 8, right? 10 minus 2 is 8. So you can write the A double prime is actually 8, 8. I hope you understand. You can actually, for translation, we can use a matrix method to do, right? So the final answer is 8, 8, must write in coordinate, all right? For A double prime, which is the final image. Okay, so when you want to do the translation, you can always count the box, or we call the grid, carefully to double confirm we get the answer, which is 8, 8, right? Okay, you can use the matrix method to double check because sometimes the question gave to you is actually out of the graph or the grid, so you have to use a matrix method to find the answer. All right. See to next question. The diagram on the right shows that F is the image of D under the combined transformation GF. It is given that transformation H is the refraction on the line x equal to 6. Describe transformation G. So that means F is the final image, right? So under true transformation. So now we need to find the first image after we do the H. What is H? H is refraction on the line x equal to 6 because it's a vertical line that cut the x-axis. So let's show how the object D refracted on the line x equal to 6, and we will get the image of D prime. So from the D prime, then we will do the G. Now let's zoom in carefully the object and the image, D prime and the F. F is the image and D prime is the object right now for the transformation. So let's do slowly again. So let's mark the object with 1 point and the corresponding point for the image and the pink color. And then we join the line, okay? You can use a dotted line, okay, between the object and the image corresponding point, and you divide the line into 2 equal balance sides. So you draw a midpoint first and you draw a line, and make sure you use your ruler. Measure is 90 degrees. You know your ruler, there is a scale that you can use as a 90 degree. So you just draw a line which is 90 degree to the blue line, okay, the green and the blue perpendicular. Now we find another pairs of the object and image, all right? So for these pairs, we are going to divide them into two equal balance sides. So we find the midpoint first and we draw the line. Make sure the line is perpendicular to the line connecting to both points. So these two lines, for sure, they will intersect, and the line of perpendicular bisector will intersect at the point of rotation. So it's labeled in green color. So if you read, the point is obviously is 3, 6. The x is 3, the y is 6, right? So the point is 3, 6. So let's see, if we rotate the arrow, you notice that this arrow will be following the anti-clockwise direction, and it will overlap at the pink color there. That is the final image, all right? So basically you must understand that rotation, you have to find the center of rotation, and the concept that you use is you use a perpendicular bisector. Okay, so then you write your answer: rotation of 90 degree anti-clockwise at the center 3, 6 in point form coordinates. All right, so you will be given 3 marks in SPM exam if you write like this. Okay, so make sure you have 3 important points: rotation and the direction and the angle and the center of the rotation. Okay, so let's proceed to the next question. Okay, for number 7, based on each of the following polygons, design a tessellation using isometric transformation. So we are given the isosceles triangle. So let's tessellate the triangle. Tessellation, it means that we are going to duplicate, I'm going to photocopy exactly the size, the same size, and we're going to paste it until no gap between each of the shape. All right, there is no empty space between the shape. All right, so let's tessellate the triangle. So we can actually rotate, okay, isometric transformation. So we just rotate. After we rotate, we translate. You see or not? So we have to use the isometric transformation. So we keep on translate. The shape consists of 2 isosceles triangle. And then we can actually add on the two isosceles triangle in between them so that there is no empty space between the shape of the triangles. After we get the whole shape, we can just copy and paste, right? So that's very interesting about tessellation. Now let's do another tessellation trapezium. So let's just design the trapezium so that we can see the shape is repeating. So we can rotate. Okay, isometric transformation, we do rotation, and then we do refraction and do translation, right? So then we keep on we can keep on actually translate the object and refract the object, the whole uh, design that we just create. And then for pentagon, let's see how we do using isometric transformation. We can actually rotate, right, 180 degree, and after that we are going to translate, right, translate, and then we keep on repeat the shape. Okay, that is one way we call translation. After that we can do reflection. Okay, so that is actually the shape of the tessellation. How about hexagon? For hexagon, let's see, first of all, we design the tessellation by rotation. Okay, we rotate 180 degree. Then after that, we will rotate again, right? 120 degree. And then we will translate. Okay, we'll translate. And then we will, maybe we can say that we translate, or we can do refraction if we want. Okay, that is the actually the design for the tessellation by using either one. We have either refraction, we have rotation, or translation. All right, so let's question number 7 about tessellation. Let's proceed to question number 8. Okay, the diagram below shows two quadrilateral PQRS and TUVW drawn on a Cartesian plane. So let's discuss how to do this question. Okay, so quadrilateral TUVW is an image of quadrilateral PQRS under the combined transformation MN. So we'll do N first, followed by M. So the object is, okay, PQRS the object, so we will actually do enlargement. So the blue one will become the green one. So actually that is enlargement with a scale factor which is less than 1, because the image will be reduced, right? The green one is smaller than the blue one, and the center of the enlargement is 6, 3. Followed by, we'll do reflection in the line x equal to 5 to get the final image, which is TUVW, right? For the image for the combined transformation for MN. So we will solve the question by using the concept of enlargement. So you see the blue one will become green one, that is the first image, and then the green one will be refracted about the blue line, which is line of refraction, to get the final image, which is pink color. So we will describe N as enlargement with a scale factor 2/3 is the pink one over the blue one, because its scale factor is length of image over length of object. And then the center, it should be at the 6, 3, right? Obviously that is the center of the enlargement. Followed by, after we do the N, we do M. We will refract the green one into the line of refraction, which is x equal to 5, to get the final image, which is pink color. So the area of the image is equal to k squared times area of the object, right? So since the area of TUVW is 10, and TUVW is the image, right? So area of image is 10. K, we have the K which is 2 over 3 because the image becomes smaller. So we need to take 2 over 3 and then we need to square it, right? So the scale factor is 2/3. So we have to square it and then we times with the area of the object. Actually, we are not sure area of the object. So we can say that area object is area PQRS, or you can say that it's X. So after you solve it, your area of PQRS should be bigger than the 10. So the answer is 22.5 unit square. That sounds logic answer. Alright, because when you do enlargement, the image becomes smaller. Okay, so that is actually how you answer the combined transformation question. For next question is question number 9. The diagram on the right show two circles with the same center O. The large circle is the image of the small circle under an enlargement at center O. It is given that the radius of small circle is 3 cm and the area of the cut region is 47.25 pi centimeter square. In order to find the answer for the scale factor, we need to use a formula k square equal to area of image over area of object. Since the area of the color region is 47.25 pi, so we are asking to find the area of object. So the object is pi times 3 square because the radius was given 3 square, and divide by area object which is 9 pi. So we can cancel out all the pi and we can solve the k because k square is 6.25. So the answer will be 2.5 with a positive and negative answer. But we will choose the answer which is positive because it seems like it is actually showing that the object and image at the same direction. Now let's go through the question. Jurina built a pinhole camera to observe the image of a tree as shown in the diagram below. It is given that the scale factor is negative 1 over 80. So the negative actually showing that image and object are at the opposite direction from the center of enlargement. So what is the distance between the tree and the image? So we are going to find the distance for the object to the center and the distance for the image to the center of enlargement was given in the question. So in order to answer this question, we have to use the formula for scale factor. The scale factor here is negative 1 over 80, right? So it shows that the image and object are at the opposite direction, from the center of enlargement. So we are asking to find the distance between the tree and the center of enlargement. Okay, so we have to find the distance for the center of enlargement to the real tree. Because the distance for the image to the center of enlargement was given 15, so later we can just plus with the 15. So the scale factor was given by distance of a point of image from the center of enlargement over distance of a point of object from the center of enlargement. So we have 1 over 80 equal to 15 over x. So we will solve it using the cross multiply. So we will get x is 1200. Bear in mind that the negative no need to write in the formula. It's just telling you that image is at the opposite direction with the object. Okay, once you got the x, you just add on to the 15, so you will get the answer for that. So the answer is 1200 plus the 15, so it's 1215 centimeter. Alright, so we just plus 15 with the 1200 to get the distance asking by the question. Hence, the distance between the image and the tree is 1215, right? Centimeter, right? Okay, so you just take 1002 plus 15 centimeter to get the final answer. Okay, let's proceed to the last question. All right. Question 11. Madam Noria has a trapezium-shaped piece of land. She divided her land into 3 congruent sections. Keywords: 3 congruent sections, right? As shown in the diagram on the right, calculate the perimeter in meter of the land, the area in meter square of each section of the land. Okay, so let's label everything. So we measure congruent means all the sides are the same, all the angles are the same shape, okay, same size. So everything the same, corresponding angle, corresponding side. So we just find the length for the slanting part. Okay, we can just add up all the length. So it's 200 plus 80 plus 120 plus 80 plus 203 plus 203 961 plus 320. So the answer is 1003.961. And the area for each of the section of the land is 1/2 times 80 plus 120 times 200. So it's equivalent to 20,000. All right, so that is the answer for question number 11. Okay, last question. Okay, you are given a pentagon, regular pentagon, and JKLMN is a regular pentagon, and the triangle JNM is an image of the triangle JKL. That means JKL is an object, right, of the combined transformation XY. So for a regular pentagon, we know that the total internal angle is n minus 2 times 180 degree, which is 108. So we have to find the angle for one of the given 36 degree, 108 divided by 3. So that means we are going to rotate this triangle JK, okay, JKL, which is an object. The blue one is an object. Now we rotate. Can you see that? We rotate with the 36 degree. After that, okay, we write rotation about center J, 36 degree anti-clockwise, right? Rotation of 36 degree anti-clockwise at center J for Y, followed by Y. After Y, we will follow by X. So X obviously is a reflection, isn't it? On the line, the green line is JM. So it's a reflection on the line JM. So that is the combined transformation Y followed by X, but we call as XY. Be careful. Okay, that's all my sharing for the homework for today. Till then, bye bye and have a nice day.